Welcome to lecture 6, chapter number 2 for numerical of turnbuckle. So today I will explain you one numerical of turnbuckle. Let us see what is given in the question, students. So the pull in the tie rod of a roof truss is subjected to 50 kilonewton. Design a suitable adjustable screwed joint. Permissible stresses are 75 megapascal in tension, 37.5 megapascal in shear and 90 megapascal in crushing. First of all, we'll write down with the given data. 50 kilonewton, that means 50 into 10 raised to 3 Newton. Tensile stress is 75 megapascal, tau is 37.5 Newton per mm square and crushing stress is 90 Newton per mm square. As we can see that adjustable screwed joint or a turnbuckle is having threaded members which are more subjected to failure because of stress concentration. So we need to make our design safe, and that is why we will be taking 30% extra load. So design load will be 1.3 times the given load. So it comes 65 into 10 raised to 3 Newton. And we will be able to find out various dimensions as this. First step is to find the dimensions of the tie rod. That means core diameter, nominal diameter, then pitch, etc. For that, we have considered the tensile failure of the threads at the root. And strength equation P is equal to pi by 4 dc square into sigma T. So substituting all values and rearranging the terms, we will be able to find the core diameter as 33.2 mm. After we find core diameter, first method is to find out the nominal diameter by using standard table given to us. There are two types of threads, coarse threads and fine threads. So here for turnbuckle, we will be using coarse threads. And from that table, next higher value of core diameter is 33.2 millimeter. Say next value is 34.093 mm. And corresponding nominal diameter is 39 mm and pitch is 4 mm. We will see the table in the next slide. Second method is if table are not available, then nominal diameter is equal to dc upon 0.84. So we will be taking it as 33.2 divided by 0.84. So it comes around 39.5238. Then we will round it off to 40 millimeter. Core diameter, again we will be multiplying it nominal diameter by 0.84. So new core diameter is 33.6 mm. Now we will round off the core diameter, say 34 mm. And pitch is equal to DO minus DC 6 millimeter. Let us see how the tables are there in the industries. First column is indicating metric threads designation like M34, M12, M22, etc. Second column is giving pitch value in millimeter. Third column is giving the major diameter, that is DO. We denote by DO. Then effective diameter, we write small d. Major or minor or core diameter of bolt is DC and nut is here in sixth column. And here depth of the threads, and here there will be a stress area. Our value is, you can see here 33 point something was our answer, and fifth column next higher value we can see is 34.093. Corresponding to that core diameter value, each is 4 millimeter and nominal diameter is 39 mm. And that is what I have shown you in the previous slide. Step number 2 is to find the length of the coupler nut considering shear failure of threads of the rod into the threads of the nut. So strength equation is P is equal to pi into dc into L into tau considering circumferential shearing. Substitute all values and we get value of length as 16.2 millimeter. Now friends, we must check that our value lies in the range or not. Range's minimum value is DO. So because 16.2 does not lie in the range, so we need to increase length of the coupler nut by minimum value, and we will be now using length as 39 mm as the safe value. Third step is to check length of coupler nut for crushing of the threads. As we have taken data from the standard table, pitch value is 4 mm and N, it is 1 upon pitch, so it comes 0.25. Strength equation for crushing failure of all number of threads in L millimeter length, E is equal to pi by 4 DO square minus DC square into N into L into sigma C induced. Substituting all the values in this equation and rearranging the terms, we can find that sigma C induced is 23.6 Newton per mm square. Our permissible value is 90 megapascal. So as this induced stress is less than permissible value, therefore design of threads is safe in crushing. Fourth step is to find the diameter of the coupler nut, capital D. For that we will be considering tensile failure, and strength equation is P is equal to pi by 4 D square minus DO square into sigma T. Substituting values and rearranging the terms, we will be able to find capital D as 51.22 mm. Now let us check that whether it lies in the given range. So range is from 1.25 times DO to 1.5 times DO. 1.25 times DO is 48.75. And as we can see that our value is more than the minimum range value, therefore this D is satisfactory and we will be considering 52 mm as the safe value. Fifth step is to find the diameter of coupler, that is inner and outer diameter of coupler. Inner diameter, we use empirical relationship as DO plus 6 to 8 mm. So it is 39 plus 6 mm. It comes 45. Considering tensile failure of coupler, strength equation is pi by 4 D2 square minus D1 square into sigma T. Substituting all values and rearranging the terms, outer diameter of coupler is 53.6 mm, whereas our minimum range is 1.5 D. So minimum range value is minimum 58.5. Our value does not lie in the range. So for a safer side, we will increase the value of D2 and we will be using minimum either as 58.5 or we can round it off to 60 mm. So outer diameter of coupler is 60 mm. Last step is an empirical relationship, that is length of the coupler is taken as 6 times DO. So it is 6 into 39, so it is 236 millimeter. And these are all the steps for the numerical of turnbuckle. And I know you have enjoyed this numerical and keep doing more sums also. Thank you very much.